Hi, we are Timebeat. We develop hardware and software to keep your network in perfect sync. Have you ever noticed how systems that maintain state often rely on consensus? More than one copy of something is typically required for us to be sure it's correct. For example, Kubernetes relies on etcd. Elasticsearch uses a master node election process. Systems like Raft, InfluxDB, and others all depend on consensus. Even UTC, Universal Time, is based on consensus. It's not just one clock, but the average of around 400 clocks around more than 80 global locations. At NIST alone, there are 10 to 15 clocks. These clocks are combined using a weighted average to produce one unified time. That time is then fed into 4 different GNSS constellations. Now, if you're in a data center with a PTP grandmaster clock, it might be tracking 20 to 40 satellites in parallel, pulling in up to 80 signals. Again, consensus. But then, something strange happens. Once we enter the data center itself, the paradigm shifts. Suddenly, every node and every link becomes a single point of failure. If a boundary clock fails, everything downstream fails with it, and time errors can be introduced without you noticing. At Timebeat, we entered the clock synchronization space because we saw too little innovation in the industry and too high margins. What we propose is to extend the consensus model into the data center. Instead of relying on a single time source, we've built a system of 3 fully independent clocks, all in one rack unit. And this 1U rack unit with 3 clocks, it costs about half of what competitors charge for just 1 clock. The system has dual network ports for connection to redundant network fabrics. Around the back, you'll find input and output ports that allow each clock to compare its time with the others. Every clock can see every other clock. Inside, it's completely modular. Oscillators from multiple vendors, GNSS receivers from multiple vendors, dual oven-controlled OXOs, the highest-end oscillators, atomic clocks, either Rubidium or Cesium, redundant power inputs, front and rear. You can pull one and it keeps running. Despite being less than 5 inches wide, these are not weak devices. There's serious capability inside these units. Some of our customers use them in exchanges where GNSS access is restricted. In those cases, time is provided via PTP feeds from the exchange. But here's the problem. Those feeds don't always agree. And that's where our consensus architecture shines. If 2 or more feeds agree, great. But the moment consensus breaks, we automatically go into holdover because we refuse to trust a single source. That's the fundamental principle behind what we do. If you'd like to know more, drop us an email or book a meeting at timebeat.app. Thank you.